Cyclone Idai, which hit southeastern Africa 2 weeks ago, is a stark reminder that climate change is causing more frequent and larger scale disasters around the world. And in turn, logistical demands are growing in order to prepare for and respond to such crises. Through this webinar, we hope to highlight the need for humanitarian logistics to adapt to changing environmental conditions. And our sector perhaps suffers from a degree of complacency in this area. And so action is required urgently if supply chains are to be climate-proofed. This includes assessing the tolerance of emergency transport infrastructure to more extreme weather events, stress testing the resilience of logistics systems, and adapting humanitarian supply chains to new patterns of demand brought about by climate change. This new field of adaptive logistics, as we can call it, will prove an important development in our work to promote the latest thinking and provide practical advice to the sector. So I'm therefore very pleased to welcome today our speakers. Ralph Ontes, who is a civil engineer and senior consultant for Eco-Transit, a tool which is used to identify the environmental impact of freight movement in terms of direct energy consumption and emissions during product transportation. Cécile Bray, who is a senior expert for climate and carbon accounting at Geodis, and Edith Mazoye, who is Global Account Manager for Aid and Relief, also at Geodis. I'm sure you'll find the webinar interesting and valuable, and following the speakers' presentations, as I said, we look forward to answering as many of your questions as you have. So I'd like to hand over to Edith to start off the presentation.
Yeah, you can go directly to the next slide. We are just going to start with a short explanation on what is the greenhouse effect. And we hear a lot and read a lot about the greenhouse effect, but you should know that it's perfectly normal and natural that actually the greenhouse effect enable lives, and if we wouldn't have the greenhouse effect, the temperature on Earth would be -18 degrees. So the greenhouse effect trap proportion of the radiation escaping from Earth, and thanks to that allows to have an average temperature of 15 degrees on Earth. The problem with the greenhouse effect, if you go to the next slide, yes, is that the greenhouse effect is getting worse. Human activities, and particularly the burning of fossil fuels, are adding more greenhouse gases to the atmosphere. And these are the anthropogenic greenhouse gases. And the CO2 is the main greenhouse gases. The Kyoto Protocol identifies 6 anthropogenic greenhouse gases, but CO2 is the main one and represents 60% of the greenhouse effect. So that's why commonly when we talk of the greenhouse gas effect, we talk of the greenhouse gas, of the CO2 emission. You can go to the next slide. And because of the added amount of greenhouse gas in the atmosphere, we have seen an increase of the average temperature on Earth. So on this chart, you see that it has been measured since the end of the 19th century. And the average temperature is rising every year. And actually, since the last 10 years, scientists have measured that the 10 warmest years on record have occurred since 1998. And the 4 warmest years on record have all occurred since 2014. So the climate change, so the global warming has been measured by the scientists, and the climate change is really happening. and it has effect. And one of the effects on the Earth is the increased number of climate anomalies. And you were just mentioning one of them, which is the Idai cyclone. If you go to the next slide, these anomalies are being reported, and there is an increased number of climate anomalies. And this is a chart of February this year, seeing the last event being recorded on Earth. You can go directly to the next slide. So one of the objectives is to limit the global warming and to adapt to the global warming. And what do we need to do? So in 2015, 196 countries agreed to limit the global warming to 2 degrees and try to limit it to 1.5 degrees. So what does it mean for everybody is that it means that we need to cut the CO2 emission globally by 50% by 2030. So 2030 being in almost 10 years, and to end the CO2 emission by the end of 2050. So the challenge is huge, and particularly in the transport sector. But we will see that because the transport sector, if you go to the next slide, the transport sector represents globally 40% of the global greenhouse gas emission. And if we don't act on the emission of the transport sector, the direct emission from the transport sector could double by 2050. Without any action for the company, from the companies and from the policy intervention. And for the freight sector, this carbon emission could even triple by 2050, according to the latest report from the International Transport Forum. So there is an urgency to act on reducing the carbon emission from the transport sector. So what does it mean for us in terms of humanitarian logistics? As it was presented by Cécile, transport is one of the highest impact for CO2 emission. Now, if we look on humanitarian logistics and the growth of humanitarian need, we see that we have a constant increasing need for humanitarian support. And among the spend of humanitarian aid, 7% of humanitarian aid is made, of the spend is made on transport. And the growing need of beneficiaries will involve a growth of transport needs in aid and relief. So aid and relief is both an actor of the CO2 emissions, but also, I would say, a victim, as directly impacted by climate change. So we see it, and we see with IDA, for instance, the impact. Next, please. So if we focus on the need of transport on aid and relief, the transport need is mainly linked to 3 types of product: food assistance, equipment, and health product. The cost of product is always presented as the driver to estimate the proportion of each type of product, but on a transport perspective, the weight and the volume are the drivers. So for instance, if we consider that food assistance is 15% of the humanitarian spend, it will need a much bigger effort on the transport perspective. So in the following part of the presentation, we will suggest ways to reduce CO2 emission in humanitarian logistics. For this webinar, we will only focus on post-emergency and development action. Emergency is not in scope
of the model and the proposal we will make. So we can go to next slide to go through the suggestion to reduce CO2 emissions. Next, thank you.
So the first step to reduce the CO2 emission is to understand where they come from. So the first things to do, of course, is to measure and understand how to reduce them. So if you start to measure the CO2 emission, you will understand where they come from, which transport mode, where location, where are the hotspots. And once you have started to measure the CO2 emission, then you can set KPIs and targets to reduce the CO2 emission and define an action plan. In terms of action plan, so this is a general presentation, but they are the action plan that you have to implement internally, that you have to implement with your stakeholders, being customers, being suppliers, and then collaborate on implementing these action plans. For us as Geodis, one of our role as well in the transport sector in the industry is also to work with institutions and collaborate with a policy to implement regulation that will help and will support globally the sector to reduce the CO2 emission. So the first reflex and the first thing to have in mind is, did I ever measure and I need to measure? Then once I have measured, if you can go to the next slide, there are 3 types of action that you can do to reduce the CO2 emission. And this framework, for you to know, is also valid when you do on your personal movement. So it's good for this framework is valid for freight movement, but is also valid for passenger movement. So the first question is, can I reduce or avoid freight movement? So is there anything I can either slow down the lead time and to avoid having different deliveries? Can I reduce some movement? Do I need every movement? Can I restructure the supply chain in order to avoid some movement? The next question is it possible to shift some freight to more efficient transport mode? So, for example, one of the questions, so you will see the different impact of different transport modes. So you might know that the most impactful transport mode is air freight. So is there a way to avoid air freight and to shift it to other transport modes? Or maybe globally on the entire supply chain or only on some of the supply chain? And by shifting some of this freight from a high impact transport mode to low impact transport mode, you can reduce your emission. And then globally, can I improve the efficiency on the entire system? So mostly for us, it will be action that the carriers will work on. In terms of vehicle, can we improve the efficiency of the vehicle? Can we improve the fuels that we use? Can we have cleaner fuels? Can we optimize the loading of the vehicle? So any question that helps to improve the freight transport movement. If you go to the next slide, this is showing the different impacts, the impacts of each transport mode. So it might not be very easy to read, but this is the usual transport efficiency indicator used to measure and to assess the efficiency of a transport mode. So the efficiency of a transport mode is measured in grams CO2 per ton kilometer. So that means that 1 ton of freight carried on 1 kilometer will in average emit between 1,200 grams CO2 to almost 2,000 grams of CO2 for air short haul. And there is a huge difference between short haul and long haul, because most of the emission from air transport are emitted during takeoff and landing. So that's why you see a huge difference between short haul and long haul. So for long haul, in average, you would emit between 500 and 700 grams CO2 per ton kilometer. If you go to road transport, there is also a difference between small trucks, so usually express transport, and between long haul and I would say full truck transport. So in average, you can estimate that for small trucks, the average efficiency of transport is between 180 grams CO2 per ton kilometer to 400 grams CO2 per ton kilometer. And then for long haul, it's around 50 grams CO2 per ton kilometer to 90 grams CO2 kilometer. Then the most efficient transport mode are barge, rail, and sea. Rail is more and more developed and used. There is a high difference in rail between electric rail and diesel rail transport. But rail remains more efficient than road transport. And the most efficient transport mode is sea transport. So if you look at sea, for example, the average emission of sea transport would be between 7 grams CO2 per ton kilometer to 20 grams CO2 kilometer. So you see, sea transport is 7 grams per ton kilometer compared to air transport, which is 1,200 grams CO2 per ton kilometer for short haul. So there is really, so you cannot always move from air to other transport mode, but you have to have in mind these criteria in order to be able to make a decision. Next one is for me.
Next. So let's look now at some very concrete example. Next, please. So the examples you will see are real ones, which were transport that we organized in the past few weeks. If we consider, for instance, a transport of 10 tons from Belgium to Iraq, CO2 emissions. So you can see the flow on the map. On the left side of the screen, and the carbon emissions on the right side in the small graph. For a transport by truck, there will be an emission of 3 tons of CO2. If we consider the same flow or the same freight, using ocean and air freight, we will multiply by 5 the CO2 emissions. And if we look at the next page, we will even multiply it by 10 if we use only air freight. So, of course, that has to be put in parallel with the lead times, and that's often what we need to do. Just as an example, for road freight, the lead time to Iraq will be 9 days by truck. So to be taken into consideration, so 10 times more emission by air freight. Then if we go on the next slide, this other example to Afghanistan, is also showing, so comparing truck and air, a CO2 emission which are 10 times higher with the air solution than with the road solution. In this case, for example, the lead time by road would be 20 days. Of course, as Cecil mentioned, the type of air solution which is used can influence the CO2 emissions. If we consider, for instance, that cargo flights will have a better performance than the mixed passenger cargo. Also for chartering, for instance, the type of plane used, the age of the plane, will also influence the impact. So all those things need to be considered. If we take next page, the last example, next page, please. Thank you, which is presenting a flow from Netherlands to Mali. There we see the CO2 emissions with a comparison between sea freight and air freight. It's 30 times higher. So you multiply by 30 the CO2 emissions by using air freight compared to ocean freight. So all those showcases, which are very concrete, have been calculated with the eco-transit tool. So this tool is used by several freight forwarders such as Geodis, but still we can support on those CO2 emissions topic. So I will now hand over to Ralph to present the eco-transit tool, which has been used to calculate those examples.
Yeah, hello. I hope you hear me, and thank you very much for this introduction. So I'm Ralph Antes from IWE, and it's a consulting company located in Hanover in Germany. And we have the project Eco-Transit World. And what is Eco-Transit World? So in the first row, it is an energy and emission calculation tool. So what does it mean? You just saw it already on the charts from Edit. So you can input any global transport chain, which can consist truck, train, sea ship, barge, airplanes, and also logistics sites or warehouses, and calculates the emissions or the impacts of these transports. So the output, what you get is the energy consumption, of course, the greenhouse gases, what is mostly used like CO2 and CO2 equivalents. So these greenhouse gases have a global impact on our environmental. And we also calculate air pollutants like SOx, NOx, non-methane, hydrocarbons, it's a bit wrong, and particulate matter. So these exhaust emissions have more a locally impact. No? You know, that discussion perhaps. However, we're calculating both, and air pollutants is quite a bit extraordinary because it's more difficult. You have to take in consideration what kind of vehicle do I have and what kind of emission class is on this vehicle. Okay, however, so you can use eco-transit by yourself, and I will show you this after the next slide. So you can use it by yourself on www.ecotransit.org. But beside this free available version, we also have a business solution. And these business solutions are used to calculate really a lot of transports automatically. Therefore, we have different kind of interfaces, so application, program, interface, API, like SOAP XML web service or CSV file upload, so Excel lists calculation. And these business solutions are license-based, so they pay an annual license fee or via consulting. Now, then we have some companies who send us their list and we are calculating this for a fixed price. At the moment, we have about 45 companies, more or less, who are calculating with Ecotransit. And just to give you an impression how much it is used, so in the last year, we calculated over 180 million transports via our interfaces. So this is quite a lot already. And so it's important to know what it's behind, and therefore, please go to the next chart. So what is behind Ecotransit? So first of all, we have a transparent methodology. We think it's the most important thing if you use any calculator that you know what is happening there. And therefore, to ensure this, we have two issues. So one is that we have independent scientific institutes behind. That is Infras from Switzerland, IFROI from Heidelberg in Germany, and Fraunhofer XML for the warehouses and logistics sites from Germany as well. And all the methodology is published in our methodology report, and you can download it in a long and in a short version from our website. The methodology behind is state of the art. Therefore, we have constantly meetings and talking about this. And this is also accredited by the GLEC framework from Smart Freight Center. And it's also conform with the EN 6258, which is a European norm for calculation of emissions, and the greenhouse gas protocol and the corporate standard. However, it's quite accepted, and that's important. And it's used by the whole sector. So we have really users which are carriers, which are forwarders. We have a lot of LSPs, of course, because it's a perfect product for them. And we have also shippers like Heineken, Henkel, or Bayersdorf, or whoever. So it's really used by a lot of different companies and with different aims. And to bring this together, we created our Ecotransit World Initiative. This initiative is a non-commercial platform for the users of the business solution. And so what do? We have once a month a TECO and a web meeting, and we are the decision makers. So the Ecotransit World Initiative members are the decision makers for the developments of the calculation tools. So that includes methodology, calculation standards. We also talk about any NGOs and initiatives. So we just try to stay up to date, and at the end we control and coordinate our Ecotransit World budget, which is founded out of the annual license fee. So it really is something which keeps up to date by themselves, including all the members who are using that. Okay, and now I try to share my screen, because there I have the website of Ecotransit. So here we go. So I hope you see my screen now. So what you see here now is a www.ecotransit.org website, the start site. And when you click now on calculation or start your calculation now, then you come to the screen where you can enter your transports. And I thought it would be a good idea when we just make a short example. So we start, for example, with 2 containers. And we use the example just from Edit, because it's quite good. So that was from Brussels. So we can click here and select Brussels. You see there are a lot of Brussels in the world. To Erbil. And yeah, not so much Erbils, but we want to have this one in the Iraq. And I can now already start on calculate. So if I do that now a request is sent to our calculation module in the background and is doing the routing and making the calculation for all the parts of the routing. And you see we have a result. And if I take a look, so I can go on distances and show all transport services on map. You see we have here the same route like just Edith shows, going from Belgium via Germany, Austria, and so on, back down to the Iraq. I think it's very important to understand that we're not just calculating a truck, we are also having a transport service. And I can show this a bit better when I go back and switch now from standard to extended. Because in that case, you see, okay, it's not only a truck, it's a 40-ton truck, it's diesel. No? So we also have, for example, CNG, LNG, whatever. Battery electric vessel is BEV. And yeah, and then we have emission standard and a load factor, and this is an empty trip factor. And in Ecotransit, I also can compare this. And so perhaps I just go to the example which Edit has and say, I want to use an airplane, but I don't want to fly directly to Erbil. I know in general, I fly to Dubai. So now I included here an via point. And now I fly from Bristol with an airplane to Dubai. And now I take the truck to Erbil. And when I start calculation now, then we see what we already saw, that's a plane type. A transport by plane is from the point of view of emissions, not such a good idea. You have a lot of emissions by using the plane, but on the other hand, it's faster. No? That's the other point. And you can also go on distances again and see how this is done. And now I thought, okay, if airplane is not such a good idea, then perhaps just use a sea ship. And there I just changed from airplane to sea ship. So I still let the truck here and include sea ship. And now happened something that Ecotransit also take a look at which harbors are the most probably used harbors here. And you see it's much lower if you take the sea ship compared. So when I go on this map, we still have a truck part here, which is from Riese. This is a port, and then we go to Erbil. So this is a route which is taken. And what I want to say is that the interesting part is that Ecotransit detects the correct harbor, or with the probably most close harbor. No? But you can also say, I want to go to somewhere in, I don't know, here in Turkey and go then to this one. But so that's the closest harbor, like the crows fly to Erbil. And this transfer point determination, what we call it, because we change the transport mode, is done by automatically by Ecotransit. So I thought, as a last example, I just put another example to it. For example, I want to go by train to Constanta, which is a harbor in the Black Sea. And then I take once more the sea ship. So now we have a train from Brussels to Constanta, and then to Riese by sea ship, and then we go by truck. So you see, this is also possible, no? That you really include different transport chains. So here we have now the fact that the train is indeed a bit below also compared to the sea ship. This is because the sea ship has to go a longer way. And on the other hand, the train could also be better than the sea ship, but it depends a bit on where you're going. No? So if you're using, for example, an electrified train in Poland, you have a high electricity, no, you have a lot of CO2 on the electricity because they have a lot of coal plants in Poland. And if you go via, for example, Norway or Switzerland, they have a lot of renewable energy in their catenary, and then it works better. And here you see the train goes down to Constanta, then the sea ship to Riese, and once again then the truck to our target. Yeah, I just can invite you just to use that. And perhaps one word regarding, it's all about CO2, but we also calculate all these other emissions. And if you take a look, for example, at the nitrogen oxides, then you see the sea ship is not so good at the end. No? So that's the other side of the picture, and the sulfur dioxide is not so good. No? But this probably will change in future because we have emission controlled areas in the sea and so on. But you can calculate this with Ecotransit by yourself, and if you have additional questions around this or business solution or whatever, you're also free to contact us, and you find our contact data on the website. Okay, that's so far from my side.
Thank you very much, Ralph. That was very interesting. So to summarize from our presenters, let's see, basically there are 5 steps to reducing carbon emissions. The first step is to measure, and that Ecotransit tool was a fantastic tool to be able to access. And so I hope that organizations that are aware of it, and we will through HLA make sure that there's more awareness of that tool. I think it would be fantastic if we can pay more attention to the importance of using the Ecotransit tool as an example of how to measure capability in place of, and to place realistic targets that can be shared internally in organizations. Secondly, there's a need to consider CO2 emissions when selecting a transport mode as a means to achieve emission reductions. And we saw the impact of each transport mode in the earlier examples. Thirdly, there's a need to collaborate at a more tactical level with the private sector, so carriers, logistics service providers, etc., to define low carbon solutions through selecting the best routes and modes as was described by Ralph, and to start to create a more positive trend for the humanitarian logistics sector. Engagement in humanitarian logistics processes will be a key to successful CO2 emissions. Fourthly, where feasible, there's a need, of course, to reduce empty space in containers and trucks, etc., as much as is possible. And that's done through better planning. And finally, to consolidate shipments with other humanitarian organizations or private sector partners through sharing common assets, trucks, containers, vessels, aircraft, as a means to improve the utilization and reduction of costs as well. So thanks very much to all of the speakers, and particular to Edith and my colleague Nicola for organizing today's events. I'd now like to open up to any questions. So we don't have any questions posted on our Q&A chat, but I just need to, I'll offer you a couple of minutes to post any questions. Otherwise, I have a few that I could ask myself.
George, we have one question from Will Heegard, which will actually be a question for Ralph. Ralph, is anyone aware of tools to analyse the CO2 reduction of pre-positioning supplies?
So I'm not sure if I get the point, but So in principle, what we from Ecotransit do is not to judge any transport type or to say you should do this or that. So what we provide is a calculator in the first step, and our aim is to have a realistic calculator which creates correct emissions. So, and the point is that the companies who are using that, they can use the results to create ideas and actions out of it. And of course, if you have pre or post carriages, then of course you can take care to make this via different locations, perhaps. No, it must not only be a model split, it can also be a better supply chain. So perhaps this is also something Cecile can answer on it. She has to unmute, I guess.
Of in the aid and relief supply chains, but basically the tool is that you need to define different scenarios and measure the difference between the different scenarios. So I don't know if that answers the questions, and maybe someone can help us with the prepositioning supplies. What is exactly expected?
Okay, thanks. We're just getting a few more questions in here. So there was another question. So you wanted to, is anyone aware of tools to analyze CO2 reduction of pre-positioning supplies? No, well, certainly I'm not aware of that. It has been, I'm aware in my past life of considering this, but I don't think that there are any tools particularly related to pre-positioning.
I just see one question: if we plan to open access to the humanitarian NGOs, and yeah, we just talked a bit about it, and we will have our meeting next week in Paris. So I will put this on the table, and I could imagine, so perhaps not for free, but at least for a fee which is not creating. So just to have our effort founded, but I could imagine that we will include special fees for NGOs, and for this perhaps you just have to contact us, and then we will find a solution for it. It depends a bit on the issue.
Yeah.
George, we had another question in which I think could be for you from one of the attendees. The question is, if donors allow buying locally medical commodities that suppliers have brought in, usually by sea, versus flying them, that seems to be one of the options for reducing CO2. So not so much of a question as an observation, but I wondered if from your previous NGO experience you had any opinion on that.
Well, certainly the best option where feasible is to use local market suppliers. And so the challenge there, of course, is making sure, particularly when you're talking about medical commodities, that quality can be assured. There has been a lot of work done in recent years to support the development of the local production of pharmaceuticals in different contexts. And so, yes, it's definitely an option that needs to be considered. And this comes back to the importance of better planning and better disaster preparedness, essentially, in terms of organizations needing to ensure that they have identified well ahead of time the various sources of supply, the various local sources of supply.
It's exactly in link with what Cécile presented, which is the first step, avoid. If you can avoid to make those long transport, that's the first and best way to reduce. So it's step one, avoid, and local production is definitely enabling to avoid.
Just one comment also in addition for me, Cécile, I saw a question, should consider both CO2 and transportation costs, of course, and this is when we are, when it was meant in the presentation, collaborate with your carriers. Of course, we do that Geodis with our customers. We would present, we are able to present different scenarios, presenting what are the cost, the lead times, and the CO2 emission of the different scenarios. And based on these criteria, then you would be able to work on the different scenario and select what is best for you. But that's not something that EcoTransit tool is providing. It's then a discussion that you need to have with your logistics service provider.
Yes, thanks very much. Okay, are there any other questions?
Yes, of course. Contact emails, of course.
Yeah, okay. No, I mean, I suppose one for me was particularly, I think, considering what's happening in the response to the cyclone Idai in southeastern Africa at the moment, where because it's a sudden onset emergency, there's a very strong usage of air transport, particularly for last mile operations. And so this is very challenging, of course, and it's something that from a emissions management perspective, is difficult to tackle. I just wondered if the presenters had any reflections on that issue.
It's an extremely difficult question to answer. Of course, I don't see any other solution than using air freight. The only thing you find, there are a few things still you can work on, is optimizing the load and avoiding multiple trips, avoiding empty space, because I suppose that I don't know if it is the case in humanitarian logistics, but I suppose that everybody had at some point ordered something via any platform on the internet and receiving a small box or a small order in a big, huge box, empty of full of empty space. So these are the kind of action you could work on, avoiding carrying empty space. Preferring freighter than passenger transport, preferring a direct flight. This kind of action have an impact of the CO2 emission of the transport chain.
Mm. Yeah. Yes, thank you. And I see a comment here about the are there any significant costs associated? Well, there could be significant costs associated with two aid organizations attempting to reduce CO2 emissions. But of course, I suppose it all comes back down to the need for there to be better planning, ensuring that, as you were saying in the presentation earlier, the importance of recognizing that road transport is much better to use than air transport. And so, when there is an ongoing humanitarian operation, the use of road transport assets is obviously preferable and should be cheaper.
George, Will's latest observation about NGOs procuring carbon offset certificates, have you any experience or evidence of that?
So I think the procurement of carbon offset certificates is something that has been around for a number of years. I think that there is more interest, or a renewed interest, in the issue of carbon offsetting, and something that that the HLA perhaps could follow as part of our information sharing processes. But I don't have any specific information at this stage. So I would, I think we can bring the webinar to a close, and by saying that you know, those of us working in the humanitarian logistics sector must now make an urgent contribution to tackling climate change, and you know, it's important that knowledge is shared, and that's one thing that the Humanitarian Logistics Association is aiming to do through our webinar series and through our platform and other social media channels. We see that knowledge is a key to the future success of humanitarian logistics services, and so your support to the work that we are doing is very valuable, and we'd like to encourage you to join HLA if you have not already done so. And for more information, please go to our website. So I'd like to thank again our panelists for their time and the very, very interesting presentation. Very good to know about the Eco-Transit tool. And we'd like to thank you all for joining today. Thank you very much, and goodbye.
Thank you. Goodbye.
Thank you. Goodbye
Thank you.
to everyone.
Goodbye.